Hello everyone, this is Codyssi day, what is it, day 13 or 12? I don't remember. It's Codyssi day 13, and I'm recording this a little bit late, but if the input will be not too hard to parse, I will try to do this in C++, so it might take a little bit more time, but I think it's a good occasion now that I'm not competing for the time. If it's it might be a good thing to sort of get back in touch with C++ a little bit if I can. Let's just read the problem first. So we're here. Okay, let's read the problem. That's the input. Okay, not great. This looks like a graph. Start and path length, sure. Suitable path. Directed graph. STT is the start. Each path assume length 1. Find the length of the shortest path from your location to each location in the file. Of these paths, find the product of the lengths of the 3 longest paths. Sure. Okay, this should be easy. I'm gonna do this in Python. Then maybe I will do like part 1 in C++ as well. So, I'm recording, right? Yes. Test. This is the test. So this part B1. It is I have to read the split lines for line data. Source is what we can do. Source is split on this. Let's already parse this. So the test is going to be test.split. So test cost is going to be test.split. G, and G of source is going to be test cost plus G source test cost G. Okay, now just go. do while q distance current is q dot top left, and if current not in so yeah, so if current not in g, not in dist, we do dist of current will be distance for so we just do, we don't care about this test in g of source of current, and we do q dot append test. We do this only if test not in dist. And this here, there are 5. Those are path lengths. Okay. So this is just Dijkstra. So from heap q import heap pop heap push, and what we're gonna do is this time what we do is instead of doing this, so q is just going to be this, and here heap push cool, and we put in this stuff, and here is heap pop q. This stuff is the same. Yes. then what we do is yeah, it's the same here. Just do hip push q distance. Here it's cost q distance plus cost and test. It's literally the same. I don't know if it's right. So 4 so yeah, that's the same. Part 3. If we say a cycle, which cycle? A cycle is defined as a path starts in the same location, visits any location at most once. At most once. So it is a Hamiltonian tour. And that cycle cannot visit its starting location in the middle of the cycle. But that's fine. Like ABCA is a cycle, but it has to visit. Okay, no, it's not Hamiltonian because you don't need all of the nodes to visit all of the nodes. Starts and ends at the same location. ABCBA no, ABCA DA no. Longest cycle. Note that your cycle does not need to include STT. Okay. Okay. So now we have these. We have the paths. Can we use the paths? Can we somehow use the paths? I don't think so. I mean, we have to find the longest cycle using the paths in your file. Longest cycle. I think that here we're gonna do it this way. So we can just do DFS and so explore all of the possible paths. And every time that we end up on the same node, we can yeah, so we do backtracking. Okay, so we're gonna do this way. So we do def DFS and we're gonna do visited. I don't think we need any of this stuff. We just need the G of the stuff. We just do. So DFS will take the graph, the current path len pass is this, and I guess that's it. So what we're gonna do is we're gonna say, so if current in visited, the thing is that okay, small cut here. I spent a huge amount of time, I don't know why, in writing this DFS, this stupid DFS. I was just so rusty on this stuff. Basically, what you do here is a brute force search. This was very stupid. There's probably a better algorithm to do this, but I just start in every possible key, so in every possible node, and then I run a DFS every time that I end up in the same node as the starting node. We add that to the cycles, and otherwise we just try we try another path. So we add to visited the node, and then we backtrack with by removing the node. So this is simple DFS plus backtracking to detect the cycles. And the answer was 382. Since the graph here is not that long, you can just do this and it just works. Works also on the test input, obviously. Okay, see you next time.